In our last video, I recall that we tested out using ordered pairs, and we tested to see if the ordered pair was a solution to a system. So we had two linear equations. We tested an x and a y in each of them to see if they had a relationship of some kind. So now we're going to take two linear equations and we're going to graph both of them as a system on our graphing board. Now, as you remember from the past, what I'd like to do is I'd like to take each of these linear equations and I'd like to set it up in slope-intercept so we can graph it and see what could possibly happen. The first thing that could happen will be this. Several things can happen, but this is the first one. When I graph these, I'm expecting them to cross or intersect at a certain location. We'll find out what that location is. So this first one is called lines will intersect. There is only one solution. Wherever they cross, that ordered pair is the only solution to this system. So let's go ahead and set this up in slope-intercept, and I'll help you with that. And then we're going to graph it and see where it crosses and what the one solution is. That solution, well, we'll find out. Okay, let's remember we're going to start with y. So we're going to do y equals, we're going to move the negative 3x to the other side. That becomes a positive 3x, or just 3x if you like, minus 10. Now I'm ready to graph that. I just want to put a 1 underneath the slope. So there's my positive 1. So I'm going to go to a negative 10 on the y-axis, and then from that point I'm going to go up 3 to the right 1 and draw my line. So let's go from the origin down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here. And I'm going to go up 1, 2, 3, and over 1. Now I'm going to draw a nice long line. All right, that's the first one. Now let's set this one up in slope-intercept. We have a negative y. Negative y equal, move your x over, it becomes a negative 1x. Negative 1x plus 6. Since we don't have a positive y, we need to divide everything by the negative 1. Negative 1 all the way across. Negative into a negative is a positive y. Negative into a negative is a positive 1x. And a negative 1 into a positive 6 is a negative 6. You know that slope has to have a bottom, so I'm going to put a positive 1 underneath there. This says go to a negative 6, and from there up 1 and to the right 1. So let me go to a negative 6. 1, 2, 3, 4, 5, 6. Up 1 to the right 1. And we're going to draw our line. Okay. Now, these two have intersected at one location. Let's see what the name of that ordered pair is. They intersect right here, so I'm going to move over 1, 2 on the x, a positive 1, a positive 2, and down 1, 2, 3, 4, 2, negative 4. So this is a picture of these two linear equations being graphed. They do have one point in common, which is 2, negative 4. So if you want the point, there it is. If you want to see a picture of that graph, there we go. So one of the first things that can happen in graphing is when you graph a system, it can cross in one location, and that's going to be the only answer, the only place that these lines will ever cross. One solution, lines intersect at one location. Okay? Now, let's go to our second one. Our second one is going to be where the lines are going to be parallel. Okay, so let me give you an equation. Let's say that we have 3x minus y equals 6, and I have 2y equal 6x plus 0. Okay? All right, now let's go ahead and set it up in slope-intercept. Then we're going to see if they're parallel, if they cross, we're going to see what happens to them. Let me go ahead and erase this and get ready for the next one. Okay, let's start with a negative y on the top. Negative y equals, move the 3x over, a negative 3x plus 6. Let's divide by negative 1. Y is now equal to 2 negatives make a positive 3x, and that's a negative 6. So I'm going to go to a negative 6, and I'm going to go up 3 to the right 1. Negative 6. 1, 2, 3, 4, 5, 6. Up 3, 1, 2, 3, and to the right 1. And I'm going to draw my line. Alrighty. And now let's work this other one right here. Let me erase this so we have room to work. We've got that one already figured out, right? Okay, so let's get rid of this and we'll do this one now. Okay. Now wait a minute. That's already in slope-intercept, isn't it? But I do need to divide by 2. Okay, so I'll divide everything by 2. 2 into 2 is y. 6 divided by 2 is 3x. And 0 divided by 2 is not 2. It is 0. Okay, and I'm going to put a 1 underneath there. Now, sometimes this happens. It's okay to have a 0 here, or sometimes you'll have nothing at all. If there's nothing there, or if there's a 0 there, it says your first location that you're going to plot is going to be at the origin. So let's go to the origin, which is right here, and we're going to go up 3 to the right 1. 1, 2, 3, and to the right 1, and as best I can do, we have parallel lines. So in this case, when we set it up and got it in slope-intercept and graphed it, they have nothing in common. There is no solution for this. There is no ordered pair that we can place in both of these and find a solution. They'll never cross anywhere. Parallel, no solution. We also refer to that as inconsistent, no solution. Okay? Now, the third thing that can happen, well, let me put it to you this way. We're going to graph a line, the first equation. Then we're going to do the second equation and graph it. But what's going to happen is the second line is going to fall directly on top of the first line, which means every single coordinate on that line is a possible answer. Consistent mini solutions. So let's see if we can create one of those for you to solve. All right. So this one's going to be mini solutions. And we call that consistent mini solutions. All right, so here's the one I'm going to do for that. I'm going to write x plus y equal negative 4. And then I'm going to do a negative 2x minus 2y will equal 8. Okay, let's go ahead and put it in slope-intercept. We're going to start with a y equal negative 1x minus 4. I'm going to go to a negative 4 on the y. I'm going to go down 1 and to the right 1, and then draw my first line. So to a negative 4, 1, 2, 3, 4. And then down 1 to the right 1, down 1 to the right 1, and we have a line that looks something like that. Now, this one needs to be put in slope-intercept as well, so let's start with a negative 2y. Negative 2y equal, move him over, what does he become? A positive 2x, true. 2x, the 8 remains at 8, plus 8. Now, I'm going to divide by a negative 2, all the way. Negative into negative is a positive y. Negative into a positive is a negative 1x. Negative into a positive is a negative 4. And you know that we need a positive 1 underneath that slope to give us our run. All right, do you notice that now that we've set both of them in slope-intercept, that it is the exact same equation? So I can go to a -4 again, which is where I am. I can go down and to the right, and I can draw the line again, but it's still the very same line. So we basically have three choices here. The first choice was that the system of linear equations, the two lines will cross at a certain location. The second thing that might happen is that the slopes, when the slopes were identical, we had parallel lines, no solution, inconsistent. And then the third one was, as we prepared these two equations, we found out that the equations were identical. Therefore, the first and the second line are on top of each other, which means every single point on those lines represents the answer to that equation. So these are the three things when you're graphing a system that could possibly happen. So think about it, and we'll give it a try when you take that little quiz.